Let's determine whether each expression represents a number that is positive, negative, or 0. We have several to do, so we'll start with part A. With 3 to the negative 4. Notice we have a negative exponent. By definition, that negative exponent transforms our problem into 1 over 3 to the positive 4. Simplifying that a little further, we have 1 over 81. 1 over 81, although it's a fraction, it is a positive number. Part B. We have the quantity of negative 3 raised to the 4th power. Notice that the negative sign is contained within the parentheses. We could stretch this out and notice that that would be negative 3 times negative 3 times negative 3 times negative 3. We have an even number of negative signs. This results in a positive 81. So we'll indicate that as a positive number. Part C. Negative 3 to the 4th power. Keep in mind this negative is not contained within any parentheses. So we'll hang on to that out in front and we'll evaluate 3 to the 4th power for negative 81. This is a negative value, so we'll label that negative. Let's do some more. Part D, 3 to the 0 power. By definition, any value raised to the 0 power can be simplified to the value of 1. We'll label that a positive number. Part E, quantity negative 3 raised to the 0 power minus 3 raised to the 0 power. We'll do each term separately, again noting that the definition of having 0 as an exponent, each piece will simplify to the value of 1. So we'll have 1 minus 1 for a value of 0. So we'll label that 0. Part F, negative 3 raised to the negative 3 power. We have a couple of negatives going on. Let's keep them straight. Our negative exponent indicates that we need to rewrite our expression with our base in the denominator raised then to a positive number. So this becomes 1 over negative 3 to the 3rd power. Simplifying that a little more, we'll have 1 over a negative 27. We could rewrite this as a fraction of negative 1 over 27 and label it a negative number.